Example 9 is very similar to example 8, but this time the unknown parameter is sigma, the standard deviation. So let's have a look at what information we get given. So let's sketch out this x distribution, and we'll shade in a region the probability that we know. So we know that for our x variable, we know that the mean is 50, so the distribution is centered on 50, and we're told the probability of x being less than 46 is this probability here. So we can shade in this area, and we know that that area there is 0.2119. Well, whenever we have an unknown parameter, we're going to solve this problem by standardizing. So we're going to take this probability statement to do with x, and we're going to standardize it to make it a statement to do with z, standard normal. So remember that z, our standard normal variable, is going to be x. Take away the mean of the distribution, which is 50, divided by the standard deviation, which is sigma in this case. Remember, this sigma squared is the variance, so the standard deviation is sigma. Don't forget to square root it to write down the standard deviation. And we know that this follows a normal distribution with mean 0 and standard deviation 1, because it's our standardized normal variable. So let's take this probability statement. X, probability of x being less than 46 is 0.2119, and let's turn this into a statement involving z. So we're going to try and get z on the left hand side. So let's take away 50 from both sides of the inequality and divide both sides by sigma, our standard deviation, which we don't know. And we get 0.2119 still. Because we've done the same thing to both sides of this inequality, these two statements are exactly the same. And on the left hand side, this is z, our standard normal variable. And we're going to leave this value here as it is because we don't know what sigma is yet. That's what we're trying to find. So now we've got a probability statement about z. So we kind of forget that x exists, and we just sketch out our z distribution just to help us think about it. So this is z, which follows normal 0, 1. And we know the probability of being to the left of this point here, this value, is 0.2119. So let's put in this value here on our axis for z. And we know that that area is 0.2119. So we can use our calculators to work out what this value is. This is an inverse normal problem. So we're going to go to inverse normal, and because we know the probability to the left of this point is 0.2119, we're going to put the tail as left and our probability as 0.2119. And we're leaving sigma as 1 and we're putting mu as 0 because that's our standard normal, because we're talking about this z distribution here, this normal distribution. So if we do that, we get minus 0.7998. So this thing here is equal to minus 0.7998. So we can find sigma now by putting these two things equal to each other. So that must be equal to minus 0.7998. And we can find sigma by rearranging this. Sigma is going to be 46 minus 50 over minus 0.7998. And we get sigma is 5.00 to 3 sig fig.